Infinite series useless? No, 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 you got it all wrong. Infinite series are extremely useful in calculus, beyond calculus, in all of mathematics, in all of science. Infinite series are extremely useful. Let me tell you why. Let me start with calculators. How do you think a calculator, this is by the way a calculator that I have in my office that is ancient but still works, I've never changed the battery but it still works. How do you think the calculator computes e to the x or e to the 1, e to the 2, sine of 1 radiant? It uses infinite series. For example, to compute values of sine of x, to approximate values of sine of x, we use Taylor approximations, the tangent line, the quadratic approximation, the third-degree Taylor polynomial, etc. But those are only good up to certain points in the real line, and then at some point they're very bad approximations. To have infinite precision in those approximations, we use what we call the Taylor series. And the Taylor series for sine of x, which is some expression which is an infinite series in terms of powers of x, is exactly equal to sine of x for any real number x. So your calculator, instead of trying to figure out what sine of 1 radian is, it plugs then in the infinite series for sine of x, x equals 1, and now you have a numerical infinite series that gives you the value of sine of 1 exactly. And then if your calculator is giving you 8 digits correct, then there's a computer program inside your calculator that is computing the infinite series to the precision you want. Another application within calculus is to do integrals of functions that do not have an elementary antiderivative. So for example, the integral of e to the x squared is not a function that I can express in terms of elementary functions. So instead of doing that, we write an infinite Taylor series for e to the x squared, do the integral of that, and now I have the function, the integral, as an infinite series. And an infinite series to compute values is just as good as a function. I can use it just my calculator does, compute values of sine of x. I can find values of the antiderivative of e to the x squared. If you have heard of Fourier analysis, which is fundamental to communication signal processing nowadays, Fourier analysis is also based on infinite series. We're coming up with some infinite series in terms of trigonometric functions that approximate functions. And finally, there is a hidden value in learning about infinite series, and is that it's a very good way for students to wrestle with the concept of infinity. Numerical infinite series is a sum of infinitely many numbers, so we have to think what that means. What does it mean to add infinitely many numbers? And it's a good way for students to get introduced to concepts of infinity and to wrestle with infinity in a different way. Calculus students have already wrestled with infinity with the concept of limit, and infinite series is a different point of view, a different take of infinity that people have struggled with for a very long time. For example, the Zeno paradoxes of motion are some riddles that were stated some 2,000 years ago, and that people today still struggle with because they get to the heart of how unintuitive infinity can be, and in particular, how unintuitive it can be to add infinitely many numbers. And when you study infinity in that way, when you study infinite series, you are asking the student to understand infinity at a whole new level.